we'll be going over how to find z-scores in Excel and in R. Recall that the formula for a z-score is the value of the observation minus the mean and divided by the standard deviation. In this dataset, we have three groups of students, T, M, and V. And these three groups of students took the SAT. And we want to find z-scores for each of their SAT scores for each of these three groups. So first, we'll need to start by finding the mean for each of the groups. So we'll use our average formula. And highlight and select. And we get our average for the T group. And we'll do the same for the standard deviation. And there's our standard deviation for the T group. And we'll do the same thing for each of the groups and calculate the average and the standard deviation. Once we've done that, we can calculate the z-score for each of the scores in each of the groups. So for our T group, we're going to write a formula that says equals the observation minus the mean for this group minus the mean for the group divided by the standard deviation. And by clicking that little square here, we can apply the formula to each of these different values for the whole group. And we have all the z-scores in this column now for every score for our SAT group T. We're going to do the same thing for group M. So we take our observation minus the mean for the group, so that would be column J, row 2, divided by the standard deviation for the group, column J, because this is group M, and row 3. And we can click this little square in the corner of the box here, double click, and that will apply the same formula to all the scores for our SAT M group. And finally, we're going to do the same thing for the SAT V group and find all of our z-scores for that group of students that took the test. So we take the observation minus the mean for the group, and that would be column K, row 2, divided by the standard deviation for the group in column K, row 3. And we just click the little box, double click to apply to all. And we have all of the z-scores for all of our students who took the SAT for their scores. Next, if we're going to move into R, R makes this a lot more simple. We'll need the read Excel package again to read in our data. And what I did was just read in the same data that we just saw in Excel. And what we're going to do is find the z-scores for that data. So we can find the mean. We can find the mean using the mean function. So we're going to use the mean function and find the mean of our T group, our M group, and our V group. And we're going to store those in objects just called mean, SAT, T, M, and V for each group. And then we're going to do the same when we find the standard deviation and store it just named for the groups. Then what we're going to do is create a new column in our data frame that's called Z, SAT, M, and V. And what this will do is it calculates the z-score the same way that we just did in Excel, the observation minus the mean divided by the standard deviation, and it's going to store it in a column named for what group it's giving the z-scores for. So we just ran the line that calculates the z-scores for our SAT group T, and now we have this column in our data frame that lists every z-score for every group T SAT score. And we're just going to do the same for M, and we're going to do the same for V. And now, what we can also do is learn a little bit more about the scores in our data using the z-score. So, let's find the max SAT score for group T. The max score is a 1580 for group T. And our max z-score for that score in group T is a 2.09. And so, what this means is that this score of 1580 is 2.09 standard deviations above the average of the SAT scores in group T. And we can see this because if we take the mean of the T scores in SAT T, we see that the average is about a 1237. And if we take the standard deviation of the group T scores, we see it's about a 163.12. So, if we do 163.12 times this number here, 2.099, because our max score is 2.099 standard deviations above the average, it would be 2.099 times 1.6312, or 163.12, I'm sorry, and that will give us the amount that this high score is above the average. And we can see that because if we add this to the mean, we'll get about a 1580, or our max score. And we can find out the same about the lowest score. The lowest score in group T is a 730. And that is 3.1 standard deviations below the average for the SAT scores in group T. And that is how we can find z-scores and explore some of our data in R and Excel.